Okay, so what I wanted to do is take a moment to kind of go through the general setup, and that's what I'm calling this. And we're going to use the general setup for the lab for pretty much all of the labs that we'll be conducting this year. So basically what I do is I have my VHS box spectrometer there. As you can see, I have it taped down. I'll talk about why here in a second. And essentially the light source that we're going to be using, if you're looking at your lab kits, or if you are just curious about what light source I'm using, is I'm just using an LED, a white LED in a coin cell. And so essentially hooking up these guys here, and then I'm using that same white clip thing from the very first video with the laser pointer to hold it all kind of in place. And the reason why we're using this is for a couple reasons. Number one, it's super duper cheap. You can buy hundreds of these LEDs for almost nothing. And number two is it emits a continuous spectrum. So knowing that it emits a continuous spectrum, we can do a lot of analysis based on that. So I have the guys set up. I'm going to orient it so it's kind of all the lights kind of shining into the slit of the device. I will talk a little bit later about maybe some pointers about orienting this light and kind of finding out the intensity when we look at the spectral workbench. But ultimately what we're going to be doing with this device is we're going to be comparing intensities of light at various wavelengths. So as you could probably imagine, if this LED were to move just a little bit, the comparison or the intensity of the light from our initial samples is going to be different. So what I've found is super useful is to go ahead and tape this thing down. And so essentially once this guy is taped down, and I'm just using some electrical tape here, ideally it wouldn't move the entire time. And what we can do now is we can continually move samples in and out of this area without worrying about our initial baseline or the thing that we're going to compare the continuous spectrum to without it changing. So okay, so a couple of examples. The first one is looking at these transparent films that we'll be doing throughout the year. And like I said, I think I included a bunch of different colors in your kits, or you can use a bunch of these different colors. These were like binder dividers that have been cut up into little 1-inch squares. And so what we can do is we can set it between the LED source and our device. And what we can do is we can just now run the analysis and we can do some comparisons from there. So essentially all we're doing is leaning it between. Perfect. Another one, and right here I have a sample set up in a cuvette already, is all we have to do is just set our cuvette in between the light source and our device. And so this cuvette currently is filled with isopropyl alcohol, or it's an extraction of chlorophyll using isopropyl alcohol. And I mean, we could essentially fill any sample that we want to in here. Food dye, milk, chlorophyll. We're going to do various ones this year. So that's basically it. I will show you in another video what the spectral workbench kind of gives us and what the data looks like when we're actually changing these samples out. But remember, biggest key here I think for us is that we want to make sure that our devices don't move, or the light source doesn't move between samples. So here's our general setup, something that we'll use pretty much from here on out. So cool, till next time.